Welcome to Module 7 of the Six Sigma Institute's Lean Six Sigma Certification Curriculum, which follows both the Council for Six Sigma Certification and the International Association for Six Sigma Certification Bodies of Knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be asking the question, what is a process? This module will take approximately 50 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete on your own at any time. You will also find several Six Sigma tools that you can download, including a SIPOC diagram and a flowchart template, both of which are Excel files. A process is a collection of tasks, steps, or activities that are performed, usually in a specific order, and results in an end product such as a tangible good or the provision of a service. In this section, we will be discussing what a process actually is, why quality is important in a process, and how Six Sigma projects can improve processes. We will talk about the 4 layers of the process, the steps, process timing, interdependencies, and even touching on resources and assignment. A process is nothing more than a collection of tasks, steps, or activities that are performed usually in a specific order and result in an end product such as a tangible good or the provision of a service. In a business, multiple processes work together to achieve organizational goals. Technically, the business or organization itself can be seen as one enormous process. Every process is composed of 4 layers. These layers are the process steps, the time it takes to complete each step, the interdependencies between the steps, and the resources used or assigned to the process, which are needed to turn an input into a value-added output. Whether physical, digital, or ideological, every process is a series of some number of steps. You can put those steps on paper in the form of instructions, often called a standard operating procedure in a formal business training or policy document, or a visual diagram known as a process map. A process map uses standard shapes and connections to create a map of a process that can be understood by most employees and any Six Sigma team member. Each step is initiated by a trigger, which can be from the operator or from a previous step, such as an automated signal sent to the system when one step has been completed. All processes take a certain amount of time, and processing time can change with a variety of factors. Process maps and documents can only record information such as the average time a process takes, or measures of variation in the process time. This information is often noted in such documents because it provides valuable information to teams, but real-time observation of a process almost always provides better information about processing time. In an effort to obtain more data about the process, a Six Sigma team observes employees actually performing the job functions in real time at various times of the day for several weeks. With just this information, you can find ways to reduce the time needed in order to complete a specific process. Almost any process in a business will be dependent upon one or more other processes. Remember, the business itself is a series of linked processes, all working towards the same goals or goal. Sometimes, interdependencies are noted on process maps. Other times, interdependencies are resource related. When working with processes during a Six Sigma improvement project, teams must be aware of interdependencies. What does any process you are working on rely? What relies on your process? The first is important because you might need help from those processes or people upstream from your process when making improvements. The second is also important because you have to know how your improvements will impact downstream processes and people. And improvement in the performance of your process doesn't do any good for the company or organization as a whole if it hinders the performance of a downstream process. All processes require some form of resources. Like a motor vehicle requires fuel or electricity in order to run, a process requires resources such as power, people, cash, digital bandwidth, computer equipment, machinery, supplies, parts, and even skill. Since someone in an organization has to approve and pay for resources, project teams must understand the resources involved, the cost of those resources, and the owner of the processes and resources in question, so that they can make appropriate requests about needing additional resources. Without an understanding regarding a process's resources, it will be very difficult to implement a Six Sigma initiative on that particular process. Processes are made up of components that include inputs, outputs, events, tasks, activities, and decisions. In this section, we are going to take a closer look at the major process components, such as inputs and outputs, as well as the many events, tasks, and decisions that turn an input into the value-added output we are seeking to produce. We will also explain how all of these components are related and interact with one another in order to accomplish the end goals of the organization. Inputs refer to anything that enters a process or is required to enter a process in order to drive the creation of a value-added output. Understanding all of the inputs to a process is important in Six Sigma because inputs are often casual or related to causal factors regarding the process. Inputs or the results of those inputs can cause errors or defects in the process. The cookies burn when the oven is too hot. The computers made in the factory don't function when circuit boards are bad. A lawyer doesn't win his case if his or her information is wrong. The oven temperature, the circuit boards, and the lawyer's information, these are all inputs into a process that can cause problems within the process itself. We also want to define inputs because we need to have an understanding of the resources required for a process to run. And we want to identify any inputs that aren't required. It's also important to understand the costs associated with the process's operation, as well as how the process relates to the processes that come before it and after it. The output of a process is the service or product that is used by the customer of the process. The process customer is not always the traditional end user who purchases the product or service. Customers can be internal or external. An example of a process serving an internal customer might be seen in a business office that employs a receptionist to answer phone calls. If the receptionist takes messages or transfers phone calls, he or she is serving both the person on the phone and the person who is receiving the call or message. In some cases, the customer of a process is not even a person. Many processes feed other processes. In a pharmacy, the process of entering data about a prescription feeds the process that bills an insurance company for the medication. From a Six Sigma perspective, an output is almost always of more value to the ultimate process than the input is. The process itself involves adding value of some kind to the inputs. Events are specific, predefined criteria or actions that cause a process to begin working. A process that performs well responds to an event just like a light bulb responds to the action of a switch being pulled. Six Sigma teams must determine what events trigger a process because it helps them understand why a process is being performed and whether the process is being run when it isn't needed. In investigating, a Six Sigma team identifies the events associated with the processes and may suggest that the relationship between the process and the event is a problem. The process may run at times when it might not even be valuable for it to do so. Tasks or activities are the heart of a process. Just as the heart pumps blood through your body, the tasks within a process pump the inputs through, turning them into the outputs. Tasks are the physical, automated, or computerized actions within a process. Events are the triggers that initiate these tasks. A task could be as simple as writing an email, entering data into a software program, or as complex as a machine that welds two parts together, a computer that processes data, or even a chef chopping up ingredients needed for completing a recipe. Decisions are closely related to tasks and can be tasks themselves. A chef preparing ingredients for a soup dish has to chop those ingredients, but he also has to decide how much of each ingredient he needs. His decision will likely be guided by the recipe and the number of people he has to feed. When writing an email, a person chooses to include certain specific information, such as an order number or customer number, because it is protocol to do so when sending this type of email. Decisions within a process are typically governed by a set of rules. Sometimes those rules are formally documented, while other times decisions are made via informal rules along with staff knowledge and experience. Processes that are governed by informal rules can have problems of consistency, even when all staff are experienced. They could have individual variations when performing a task. And, as we discussed previously, variation can lead to more opportunities for defects and a reduction in quality. You are probably noticing that processes can be extremely complex, and the relationship between all the components are equally complex. Input can be outputs from previous processes. Outputs can be inputs in the next process. A decision might result in an event that starts a new process, but it can also be the factor that decides which task begins. As Six Sigma teams work with processes, observing them, diagramming them, and measuring them, the team begins to understand the relationships of the components, and that helps them make decisions about possible improvements and changes. As teams work to improve processes, they need to understand who the process owners are. Depending on the business organization, process owners can be the people with the power to approve changes. In some organizations, the lowest level owner might not have veto or decision power about all changes, but he or she is held responsible for the performance of the process. The responsibilities of a process owner are often defined by the infrastructure of a specific business, but commonly, a process owner will often monitor how the process performs, usually using one or more metrics or regularly reported data elements. He or she understands how the process fits into the overall business, why the outputs of the process is critical to business goals, and what inputs feed the process. They not only ensure that the process is documented via the standard operating procedures and that process documents are kept current and accurate, but also ensures that the operators within the process have the resources and training they need in order to complete their jobs. Finally, all processes generate some form of data. Even if data isn't being captured, information is inherent in any process. A computer program that automatically routes work in a workflow might generate data such as the number of items in work queues, how many items were worked that day, the time items have been waiting in queues, how many items were transferred, and where those items were transferred to. A process for filling bottles with liquid might generate data such as how much liquid is placed in each bottle, how many bottles per hour are being filled, and perhaps variation between the bottles. Data is extremely valuable to Six Sigma teams because it is often how they define whether a process is in control and whether it is successful. The SIPOC diagram is often an important part of a Six Sigma project that can be used anytime you want to learn more about a process. In this section, we will be defining the process components using a SIPOC diagram. The SIPOC diagram is often an important part of the define stage of a Six Sigma project. But you can use the SIPOC diagram anytime you want to learn more about a process or understand how a process in a business environment is linked to other processes. SIPOC stands for suppliers, inputs, processes, outputs, and customers. For the purpose of a SIPOC, inputs and outputs follow the same guidelines described previously. Suppliers are the people, processes, and organizations that supply inputs to your process. Customers are the people, processes, and organizations that make use of the outputs of your process. The process itself is a series of steps that take the inputs and create the value-added outputs. The SIPOC diagram is one of the most often used tools for understanding process components and process relevance because it is so effective and simple. Teams can create SIPOC diagrams in a single brainstorming session, though effective diagramming usually requires the presence of a process owner and one or more subject matter experts who are familiar with the process on a daily basis. SIPOC diagrams are also infinitely scalable. Teams can diagram processes at a very minute level, but they can also use SIPOC to diagram an entire business. We'll walk through creating a SIPOC diagram and then provide some examples of SIPOCs at various levels to illustrate the scalability. You can create a SIPOC diagram as an individual exercise or within a team environment. SIPOCs can be created using a computer and software tools such as Word or Excel. But you can also draw them freehand on a whiteboard or a piece of paper. Freehand diagram is a valuable brainstorming tool because teams can quickly edit the rough draft of the diagram as they discuss a process. As you diagram your own processes, they can tend to look messy at first with edits, arrows, scratch outs, and inserts. You can clean that up after you have finished creating your diagram. But to start creating one, we need to create swim lanes. Next, we will define where a process starts and then identify where the process ends. This is followed by naming of the process, the defining of the inputs and suppliers, as well as the defining of the outputs and customers. You need to ensure that your understanding of the process at this high level is accurate by validating your diagram. If you have put together a comprehensive team that includes subject matter experts, the team can validate most of the information on its own. It is always a good idea to get a second opinion on anything the team is not sure about. Invite other subject matter experts or process owners to review the diagram briefly with the team and provide feedback. It cannot be overemphasized that you need subject matter experts when creating a SIPOC diagram, as they are the ones most familiar with the process itself. A failure to include them is a waste of talent, and in Lean Six Sigma we want to reduce waste from all processes, even our own. One of the best ways to create an initial SIPOC diagram during a team session is on large pieces of paper or a whiteboard. Create swim lanes by drawing them on the whiteboard or hanging a piece of paper for each swim lane on the wall. Provide the team with sticky notes and markers. Write on the sticky notes instead of writing directly on the whiteboard or paper. This lets you move components around quickly as you work through the diagram. It is okay if the diagram looks disorganized at this point. What is important is that once the diagram is complete, that you properly record it. You can take a photo of the diagram for later, but you should always try to memorialize the diagram as a digital document for later editing. We are going to take a moment now to look at a few examples of SIPOC diagrams that can be created within an organization. The first one we will look at is at the highest level and it shows the entire business as a single process. Next, we'll look at a machine automated process. Then lastly, we will look at a diagram of a factory process that is powered by people who are enabled or assisted by some form of automated machinery. This diagram shows the SIPOC for a mid-size printing company. It is a very high-level yet simplified SIPOC that shows how customers and vendors provide information and items. The printing company then turns those inputs into products such as printed business cards. The final product goes to individuals, businesses, and marketing professionals who placed the order. Most of the time, a Six Sigma team won't deal with a business level SIPOC diagram. However, if the team includes members from outside the division or company, such as vendors or consultants assisting with an improvement, then starting with a high-level diagram can help those outside the business understand the overall goals of the company. This diagram represents an automated process in a mail order pharmacy. The process in question puts labels on bottles that are being filled with corresponding medications. The scope of the process is only the labeling of the bottles. Because this is a process within a chain of automated processes, almost all of the components are machines, processes, and things. Prior to labeling, a machine sorts bottles by size. That machine feeds the labeling station as needed. After the labeling is done, another station fills those bottles, and so on. And here, we have a SIPOC diagram that illustrates how enablers might be recorded for your process. The process in question takes place in a factory that makes furniture. In this process, a person attaches legs to a bar stool on an assembly line. For the purposes of this illustration, leg attachment is the last step in the completion of the project, which means that the product moves from the leg attachment station to packaging and then to shipping. Without the conveyor machine, people involved in the process would have to move items manually. The conveyor isn't 100% required for legs to be added to the stool, but it enables the process to move at a more efficient pace. A case could be made that the drill isn't required either. Screws can be installed manually, but it's certainly what enables the process to move at a speed required for mass production. With just the simple SIPOC diagram of a process, a Six Sigma team would already have some idea about where variation could be hiding, what drives efficiencies in the process, and how the process relates to the overall business